Hello fellow problem solvers. So today we're going to be doing a problem from the Indian IMO Training Camp for 2019 IMO Day 1 Problem 1 test. This is a nice medium level-ish geometry problem that I suggest you try out for a minimum of 30 minutes, ideally hour and a half, not more than 4.5 hours. You wouldn't have that much time at the exam anyway, but if you'd like to go along with us, draw a diagram, put your first ideas out on paper for the next 10 to 15 minutes, and now let's begin. So what do we have here? Well, let's see, we have the incircle and points I, M, and P. So the point P is really the big point here. We need to prove that AI is tangent to the circle around MIP or IMP. So what does that mean? There's two ways to go about this problem. One is looking at it backwards and asking, what does it mean for MIP to have AI as its tangent? And the second way says, wait a second, what is this point P like? P here is the mysterious point. How do we get close to it? And one question to ask yourself is, how would you construct P? And we're going to go down that route first. And I invite you to pause for 5-10 minutes and ask yourself, how do you even get to P? Like, what defines it really? What is this tangent, the other tangent from M to the incircle? What would you do? Pause for 5-10 minutes now. And here's the big idea for me, was that, okay, what I'm really doing is I have this angle here, call this angle at X. I have this angle, it's X. And then this other tangent gives me another angle here of X. And that's how I construct P. And I have a 90-degree angle here. IAP is 90. Now, another question is, and what would it mean for the tangency condition to hold true? Well, it would mean that AIP is also equal to X. Now the question for it there is there any way I can connect this angle X, this being 90, can I connect these together in some way, shape, or form? And also thinking about the construction. Pause for 5-10 minutes and ask yourself that. And the answer for me is, well, let me add this point of tangency, call this point Q. And I'm adding it because it gives me these here are concyclic then, and it gives me another way to work with this angle over here. And now let's pause for 5-10 minutes and solve the problem backwards. And the idea is, well, if this angle was X, this angle is X, I can call it X, then also this angle would be X if the problem statement was true. Now, if this one was X, then so would this be. And then given this is 90, this would be 90 minus X, and this would also be 90 minus X. And I'll ask yourself, pause for 2 minutes, what would this mean for our problem? And the answer? Well, that would mean that this is 90 minus X, 90X. So the sum of these two angles is 180, which means that would mean that AQ and IM are parallel. Now, a question for you. Is it easier to work with P or Q? And the answer is, well, for me personally, P is distant, like it's less connected to the elements of the triangle, whereas Q is very much, it's not very much, but it's much more connected than P is to the elements of the triangle. Sure, it's hard to connect IM, but everything but P, M, and I is also hard to connect. Like, you still need to connect IM to be able to solve this problem. So with that in mind, let's try to prove that AQ is parallel to IM, right? That is the way to go about this problem. And now, for me, I would invite you to pause for another 5-10 minutes and see how would you proceed here. Pause now. And the answer for me is, well, wait a second. Let me go further and see what else would be true if AQ and IM were parallel, okay? So the answer for me here is, okay, these are parallel. Let's assume these are parallel. What is Q really? Q is if I take this point of tangency, which is very well known, it's very familiar to me. I'm taking these familiar points to connect these unfamiliar points, right? There's P is very much unfamiliar. Q is a little bit less unfamiliar, but still unfamiliar. D is very much familiar. And what I'm really doing is I'm reflecting D over IM to get to Q. Q is a reflection of D with respect to IM. And now what does this tell me? Well, this means that if AQ and IM were to be parallel, I would have DQA is 90. Now, some of you may be asking, wait, what does it make sense to look at point D? Well, it makes sense because you're talking about a tangent from M to the incircle. And if you're talking about tangents, there's two of them. And it makes sense to look at what happens with the other one. Like sometimes in problems like that can give you some structure, some more structure as to what is happening in a problem. Might give you some angles, might have some other condition that holds for it, and might have some symmetry that's involved. And that's why the other one, other tangent, is also useful. So here, so we would have, in essence, so if the problem statement was true, we'd have AQ is parallel to IM, but that would mean that AQD is 90. I'll pause again for a minute or two. Ask yourself, if AQD was 90, what would that mean now? And the answer is, well, wait a second. That would mean that here we have a point, you know, Q would really be the, if I took D, reflected over I to the point D prime here, and then intersected AD prime with the incircle, I would get this Q. That would be Q. This intersection would be the tangency point. So in essence, what I would be having is an incircle, this point D. Here I'd have A, I have C, I have B, A, I have I, and I have M. But this would be the point Q. And I would have this angle over here is 90. Now, M is the midpoint. I have D, I have I. What does this also tell me about this line AQ? This is the M is the midpoint of BC, and also MD would have to be MQ. We're still looking at the problem backwards. And the answer is, well, wait a second, I'm having a 90 here. Like this is 90, but that's what I need to prove. This is parallel to this. Is that really useful? But wait a second. What is I here? Right? What is I for this D prime Q line? Right? D prime Q is more close to IM than AQ is. Right? So what is D prime Q? Well, D is such that I is the midpoint here. Right? I is the midpoint of D prime D. And it's also the same distance from I prime Q. But I is the midpoint, and I need to prove that IM is parallel to this. Well, that means if I reflected D over here to point E, that would mean that D prime QE would have to be colinear. Now, if this were 90, that would make a lot of sense because I have a 90-degree angle here, and then this would be equal to this because M is the midpoint of BC, and if E is the reflection of D with respect to M, it makes sense that, I mean, this is equal to this then, and this is equal to this gives us a 90-degree angle, everything's fine and nice. Now, what does that make E? If it's a reflection of D with respect to the center midpoint BC, pause for 2 to 3 minutes and think about it. And this is where some theory, background knowledge is involved. That means E would be the point where the X circle touches the line BC. Okay, so that's where we've gotten. We've gotten that from our problem, which had this point P, to really just needing to prove. It seems like there might have been a step or two we might have jumped over, but it seems to me that what we have is that AQE must be colinear. In other words, if I take the intersection of the X circle and BC, opposite X circle, opposite A and BC, and if AE intersects the incircle in these two different points, then this point of intersection will be at a 90-degree angle. So now how do we prove this? What is really that saying? It's saying that if we're taking an incircle and we're taking, okay, this has been a horrible incircle, but stay with me. If I have ABC, I have D. I have D prime. If I intersect AD prime again with side E, I get the point where the X circle intersects BC. Now, how can I prove this? Well, there's two ways. This is also a lemma, but there's two ways, and that one way is to say there's homothety, and the other way is to say similarity. Now, if you don't like the word homothety, or you don't know what it means, then we'll stick to similarity. And the thing is, okay, I have this point, D prime. I want to use the fact that it's like this is its definition, and BC is really the tangent of the incircle. And I'm also trying to use the X circle somehow, and I'm trying to really prove these points are colinear. So I'm going to need some angle condition, maybe, to prove collinearity. And the one angle condition, I mean, the one thing that makes some sense to prove is to prove that D prime AC is EAC. That seems like something we could get, not directly, we know we don't have this angle directly, but maybe there's a similarity we can use to get that. And the answer is, well, we'd really need similarity which has E is going to be the point where the X circle touches BC, and D prime should also be that kind of point. And for some other triangle, but a triangle that's similar to ABC. What triangle is that? Well, we can draw a parallel line through D prime and intersect B and AB and AC at B prime and C prime. And now what do we have? We have B prime, C prime, parallel to parallel, so these two are similar. But what do we also have? What is D prime for the triangle AB prime, C prime? Well, what do we need it to be? Backwards. We need it to be the point where the X circle of AX circle of AB prime, C prime touches B prime, C prime. Now, what is the X circle of AB prime, C prime? Well, it's the incircle of ABC. So, given that, what do we have? And the answer is, well, we have that D prime is the point where the X circle touches, the X circle opposite A touches B prime, C prime. E is the point where the X circle opposite A touches the side BC in the triangle ABC. So that means that the angle D prime AC prime is EAC. Given that AC prime C are colinear, that means that AD prime E are colinear. And so we know that if we define E like this, you will have this condition. We'll have that, what's it called, if we define D prime and then E over here, we'll get that M is the midpoint of ED. Now, let's go back to our problem. I invite you here to pause for 10 minutes and try to push the problem further, finish it up, and here's a solution. And okay, so what will we say? We'll say, well, let D prime be the reflection of D with respect to Y. It's on the incircle, then by the thing we've just mentioned, we'll intersect AD prime, and it'll touch where the X circle touches the side BC. And then let's intersect it with the circumcircle at point Q. Now what do we have? We have that ME is equal to MD, and given this is 90, and this is 90 because this is the diameter, so that this angle right here, MQ is ME is MD because this is 90. Now what do we know? Well, we know that this means that MQ is the other tangent. And what does this give us? And also, what else do we know? We know that IM, let's remember that, IM is parallel to AE. So this means that if this angle is X, which is equal to this angle, that means that this angle over here needs to be equal to 90 minus X, which means what? Which means that this angle over here needs to be equal to X. So now we intersect with P, and we get this is at a 90. We know that this is also at 90. And so the angle PIA is equal to PQA, because this is concyclic, so this is X. And then we get that AIP is PMI, is equal to the angle x, and so we know what? We've proved that AI is tangent to MIP. Now I want to show something to you, which is if I just introduced points Q, E, D prime immediately, and I would write a solution like this, introduce these points, prove this fact, and then just end up with the angle chase. If I just do it like that, you don't really see the thinking that went on in trying to even why introduce E? Why are we doing this MI is parallel to A? What's this nonsense about? But if you go through reasoning, then you can see what this whole thing was about. It was about solving the problem backwards. And then the solution just pops out to be very elegant. Right? This is how you would write it down elegantly, because you're not trying, when you're writing a solution, you're not trying to explain how you came up with the solution. Nobody's doubting whether or not you've cheated, so to speak. But when you're writing that, when you read somebody's solution, you miss that. And this finishes up our problem, and as always, thanks for problem solving.